Okay, let's talk about some of the patterns that you might see as you're expanding out brackets. These expansion patterns are very useful and they're a good way to save on some time as you're working. So there's two in particular I want to talk about. The first is called the difference of two squares. Okay, so the way that you identify when this pattern can work for you is when you've got terms that are identical, but the operators are the opposite terms. So like this, there's a positive in the middle and there's a subtraction over here. So we've got a plus, we've got a minus, the operators are opposite, but we have identical terms apart from that. Okay, so let's have a look and see what happens. What is the pattern that appears? Well, let's multiply this out. This will be x squared, this will be plus 3x minus 3x minus 9. Now once I've done my like terms, I end up with x squared minus 9. That's interesting. I lost the whole middle terms. They just sort of cancelled each other out. And that is the pattern. That's what happens with the difference of two squares. The general term, it looks like this. You'll end up with the first term squared minus the second term squared in every instance. It doesn't sort of really make much difference as to what the numbers are, but this here, this is the pattern that you'll end up with the first term squared and that line wasn't straight, that'll annoy someone, and the second term is subtracted but also squared. Okay, so that's the first pattern, the difference of two squares. Let's have a look at the next one. The next one is one that is called perfect squares. So perfect squares are where everything is identical. The terms and the operators are the same. You might see it written just like this. Well, you might say to yourself, but there's not two brackets that are being multiplied out. But if you think about what is in brackets x plus 3 all squared, what does that actually mean? Well, when you've got x squared, well, that really is x multiplied by x. So if we have x plus 3 in a bracket and it's squared, well, it'll end up looking just like x plus 3 in a bracket being multiplied by x plus 3. Okay, so let's go through and have a look at what this pattern will end up looking like for this particular one. So we will go x times x will be x squared plus 3x plus 3x plus 9. So when you gather your like terms, you will end up with x squared plus 6x plus, my program went silly, plus 9. Okay, sure, but is that a pattern? Can you see what actually happened? Well, here it is. If you have a look, our first term in each of the brackets is squared. Our last term over here is the last term in each bracket squared. And the middle section is 2 times the middle 2. So the middle 2 would be 3x, and 2 times 3x would be 6x. So in general, and by the way, we actually end up with 2 general ones here, because sometimes the middle bit is positive, and if it is, it looks like this. We're going to end up with a squared plus 2ab plus b squared, but sometimes the middle operator is a negative, and if we do, we end up with a squared minus 2ab plus b squared. You might think, well, how come it's not minus b squared over here? Well, the reason why is when we multiply out the last term, the negative b times a negative b, it becomes a positive number. Okay, so there's some of the patterns that you can see as we are expanding our brackets.